A few weeks ago, we decided to build this digital carb sync tool to tune the carbs on our motorcycle using voltage. This week, we're actually building one that works just like all the other digital carb sync tools out there. This thing works awesome. It actually helps us figure out the accurate vacuum levels, kilopascals, and we're able to see all of that information on our screen. It's gonna be super fun, so follow along as I show you how to make one for yourself. Now, this whole thing started when I wanted to build a carb sync tool for my motorcycle, and I didn't really want to go out there and purchase a mechanical one, and I really didn't want to purchase one of those expensive ones out there that were close to $200 or $300. When I set out to do that, I figured that maybe we can use voltage to figure out the levels of our motorcycle. And that actually worked great. That is part one of this video series. However, I then realized that maybe we can use something like an Arduino, and maybe we can use something that will allow us to visually see the levels on a computer screen, which is what we're going to do today. So let's follow along. I'm gonna take this apart though. I'm gonna put it on our bench and I'm gonna show you each component and how that component translates to our actual carb sync tool here. It's very simple, and the information that you're going to need to plug into your computer, like the program that we're going to use, I will be able to provide that for you all. So all the work is done by me already. All you have to do is just email me at the email below. I will gladly send you that information for the Arduino program and also the HTML interface that you'll have to use for this project. And then from there, you'll be able to have access to it yourself. All I ask is that you first like and subscribe to my channel, hit that like button for this video, and we can go from there. So let's get started. Let me show you the components that I used to build this digital carb sync tool. So this is our digital carb sync tool. Now, as you can see, we have a couple of components inside. I'm gonna break this down because it looks a little bit kind of cluttered and a lot of things going on, but there's really not a lot of things going on here. First thing I wanna mention is this voltmeter is kind of stuck to the cover of this device, but it's not really serving any function anymore because we're not going to use this in the future with this setup. We used to when we wanted to measure our vacuum levels using voltage, but this time around we're not utilizing the voltmeter. So don't worry about this. I'm actually going to remove the lines first. That's what I should do. Now the 4 lines that we have here, these are the 4 lines that go to our motorcycle. We have a 4-cylinder motorcycle, so we're going to remove those for now. You don't have to have 4 lines. However, if you're tuning a carb like a 4-cylinder motorcycle, it's advisable to have 4 because that way you can get the readings faster. This right here is simply a 4-to-1 intake manifold or manifold here where you can have valves that will close and open so that you can get the reading of each cylinder. Now, the vacuum levels go to 1 line. So that means that this map sensor can only receive signals for 1 cylinder at a time. So potentially what you can do is you can just take this hose and swap it between cylinders without having to have a manifold like this, which is an acceptable way of doing it. However, I use the manifold so I could just toggle between all the cylinders and get my readings in that way. But you can do it differently. Now I'm gonna take this whole component out so I can show you how this works. I'm gonna put the box aside. There's nothing else left in the box. Here is just a piece of foam in there. Okay, so this is the whole setup. Now, as you can see here, it might look like there's a lot of components going on here, but there really isn't. Now, the first thing that you will notice is this little manifold here. This one is the one that goes to our lines that come out of our box here, but these are the ones that go to each cylinder. Now, as you can see, there's a valve here that you can toggle on and off, and that way you can get the readings for that specific cylinder. So then the vacuum then travels through here. There's a little connector here with a threaded fitting here that connects to a PVC pipe that goes all the way around through here. Now the reason that I did that is to allow for a little bit of dampening. This was the initial design that I had when we were using it with voltage. However, I don't think that you need this anymore because the sensor is actually very accurate. So you might be able to do away with this. I left it in place because I figured it might add a little bit more of dampening so we don't see fluctuations in voltage. However, the program that we're using will allow us to kind of dampen those fluctuations, so you don't really have to worry about that. So like I mentioned, the vacuum goes through here, it goes all the way around, and then it goes into our map sensor right here, as you can see. The map sensor has a little connector, little port in the bottom, and that line just simply connects to the map sensor. So technically what you can do is you can just connect this one straight to this one without having to have this PVC pipe. So you can do that if you like. Now, the main brains of our device here is this Arduino R3. Now, this you can purchase on Amazon or eBay for close to about $30. In my case, I bought mine for about $27, but you can find these out there fairly inexpensive. For the program that we're going to use, you do have to use an Arduino brand product. You can't use something like a Raspberry product or anything like that because the code is specifically for the Arduino. So I would suggest getting one of these. And then all you have to do is either get a pigtail or do like I did here and get a connector that has, or some plugs that can connect to your map sensor here. So the map sensor has 3 wires, and I'll put all the components in the description below. But basically all you have is a power source or a power connector that comes to the 5-volt connector here in the Arduino. And then you have a negative cable that goes to the negative on the Arduino. And then you have the middle cable, which is your output or your signal wire. And that one goes to your A1 connector right there. Now I chose to do A1. Sometimes, you know, depending on the program, you can move that around, but in the program that I have, you can actually just use A1 and it works perfect. Now, in this case, I will be providing all the code that you will need to run this Arduino. Again, it's a very simple process. All you need is a cable like this one. Usually you can find this in printers. All we're gonna do is connect it to our Arduino just like this, and then you'll be able to run this cable to your computer. So let me show you what the next step is so that you can build one of these. Now, if you're gonna build one of these for yourself, you can very much simplify this whole thing right here. It looks a little bit complicated, but really it's not. Again, if I were building this all over again, I could maybe build this into a smaller package where I simply have the Arduino, the 3 wires going to the sensor, and then the sensor going to this manifold, which really would be a very simple version of this design. So don't get intimidated by this. This is just something that I made because I wanted to have a little bit more dampening action in here. There's nothing in these PVC pipes, it's simply air, but since it goes from a small intake to a bigger volume, then that serves as a little bit of a dampening for our device here. So let's put it back into the box and I'll show you how the actual process went to build our interface. Now I know what you're thinking, why are we using technology for these old motorcycles, especially like these old Hondas that have points ignition and don't really have any electronics on them? Well, the reason for that is because for this program, we're able to get really good results with a little bit of money and just by using a few resources that are out there. One of those resources is actually AI. Now, I've never been an advocate of AI. However, in this situation, AI actually helped us create an interface that we can use to connect to our sensor, the one that we created with our Arduino. So how does that work? Well, the map sensor is just really a sensor that converts voltage into data. So the map sensor has a voltage range of about 2 volts to about 5 volts. So what that does is when the motorcycle pulls in a certain amount of vacuum, then that certain amount of vacuum is then transmitted back to whatever device you're using, and it tells it that there's only, let's say 2 volts or 3 volts that are going through. Depending on the voltage, then that's how the system is able to figure out what the levels of kilopascals or vacuum it is producing. Now in our case, we're using a sensor that is from 0 to 100 kilopascals. That is what they refer to as a 1-bar map sensor. Now there's 2-bar map sensors, there's 3-bar map sensors out there as well, but we don't need those because we're not turbocharged or supercharged or anything like that. So 1-bar map sensor will work just fine. Now there's different types out there and different voltages, so you might want to be careful with that. However, the cool thing about this HTML document that we were able to create, and I'll let you know what that is here in a bit, is that you're able to adjust those levels. So if you get a sensor that measures from maybe 1 volt to 4 volts, then you're able to plug it in and utilize that sensor. Now in this situation, we're using a sensor that we've had out of a Harley Dyna that we used on our last build. So that sensor is going to serve us just fine because it's a 1-bar sensor. Now, what that sensor does is it sends the information back to our Arduino, and that is where it gets a little bit more complicated. Luckily for me, I was able to go to a program like ChatGPT or to a website like ChatGPT, and I was able to simply ask the question, can you help me figure out with an Arduino how I can take the voltage from this specific sensor and create an interface that will allow me to measure vacuum or kilopascals. All I did was type in that information and it gave me back the results. What's great about ChatGPT is that it has a lot of resources and a lot of people that have maybe done this before out there on the internet. So it's able to pull a lot of information that is very beneficial. So it was able to create code for our Arduino that will then be able to send that into an HTML, basically a website looking interface that will give us all the gauges that we need. Of course, I had to customize it a little bit. So what I did is I kept going back and forth with ChatGPT, and I would tell it, you know what, can I have some gauges? Can you create a save option for these values? So more back and forth until I arrived at something that I think looks great. So let me show you how that looks. So here we have our interface. Now this is a voltage to kPa interface for 4 cylinders. And as you can see here, this thing looks great. We have 5 gauges here. They're labeled cylinder 1, cylinder 2, cylinder 3, and cylinder 4. And then we have a live gauge right here. So it's honestly very simple. So I'm gonna take my sensor here. And I'm going to take my cable. So I'm just going to take my USB cable. This is one of those printer cables that has kind of like a square end. At the other side, it has a regular USB, and then it has kind of like a it's called a USB 2, but it's also, I don't know what it's called, but it's more of a square end. And so what we're gonna do is we're gonna plug it into our computer. Okay, so once we plug it into our computer, all we have to do is just simply plug this in to our Arduino here. As you can see, it comes up, and then all we have to do really is connect our sensor here. So we press on connect to sensor, and then we choose the connection to our Arduino. So we'll hit connect here, and then as you can see, it's given us a voltage. Now I realized that this program has a lot to do with the voltage that's coming into the Arduino. Now some sensors will be where the lower the voltage, the higher the kilopascals, or the higher the voltage, the lower the kilopascals, which is in our case, that's how this one works. So it's different when you're trying to gauge voltage, so you got to be careful with that. I found that out the hard way, so don't do what I did. I actually messed up a couple of sensors doing that. So what you want to do is you want to make sure that you understand your sensor and how it works. In this case, as you can see here, we're getting about 4.9 volts. And I'm going to take my first, I'm just going to take one of these hoses, any of these, and I'm going to open it up, open the valve up, and I'm going to connect this to my vacuum gun here, or whatever you want to call this, pump, and I'm going to connect it here. So the reason I'm going to do that is to show you how this works. Now, if I start pumping this, notice how the gauge is now moving. So here we go, and we're going up to about 10 inches in mercury here, so which is about 33 kilopascals. But as you can see, now we have live actual readings on our interface here that tells us where we are exactly. Now, as you can see, the gauge is not really moving. In a motorcycle, once it's on, it will be moving because of the pulsing of the vacuum. But if you notice, if I let the vacuum out a little bit, it drops down, it keeps dropping, and it drops a little bit more. So in theory, that's how this program works. What's cool about this program, or this interface that we've created, is that now we can actually save, as the bike is running, we can actually save the vacuum of that cylinder 1, and then we can open up our other cylinder, and obviously we would have all of these connected, but then we would get the rating from the other cylinder. So in this case, I'm going to pump it up a little bit more, and I'm going to show you. So now we're at about 44 kilopascals, around there, and now we can go ahead and save that one, and now it's saving all of our cylinders in the place that they are. So once you go through it the first time, then you'll be able to see what level each cylinder is at, so that now you know where you need to make your adjustments. So once you're done with that, and you know where your cylinders are as far as the vacuum goes, then you can clear your responses and you can start all over again by getting the live voltage here. Now you can simply just use the live voltage or the live reading. Again, this is in kilopascals now, so we're not doing voltage. So you can get your live reading of kilopascals and simply just utilize that. However, if you want to save your results because you just want to go through them real quick and figure out where they're at, then now you can actually make some adjustments as you go. Again, you can just use one gauge and that would be fine. Now, if you don't have a manifold like this, you can just swap every hose to every cylinder as you go, and you can still utilize this without having to have this manifold, which cuts down on your cost for making this whole project, which I think is really cool. Now, another thing that's really cool about this interface here, and the interface is simply this website looking thing that basically shows you how this works, is this minimum voltage and maximum voltage. Now, in this, for this sensor, 0.25 and 4.75 is actually the low voltage and the highest voltage of that specific sensor. So as you can see here, the minimum kPa is 0. So that means that the minimum, that the lowest of the lowest voltage is actually going to be equivalent to 0, and the highest voltage is going to be equivalent to 100. So that means that you're able to take the measurement and compare it. Now let me show you how that looks. So I'm going to pull up a graph here, and I'm going to show you how that kind of looks on a graph. As you can see here, that is how it's supposed to look, and that is how you're supposed to get the amount of voltage versus the kPa for this specific sensor that we're using. So by looking at that, you're able to compare and figure out that that is how the sensor is actually working. Now that is really cool, because that means that if you have a different type of sensor and you look for the specs of that sensor, now you can change your minimum voltage to whatever that sensor is, whatever that sensor's minimum voltage is. So that way you can adjust accordingly to whatever sensor you have, and then you can just use that. So I think this is, I think this works great. It even has my logo up here, which honestly, all you have to do is drop in your logo to this file here, or to this, where you keep all your files, and as long as it's labeled as a PNG file, and you can save it as logo or logo.png as a PNG file, then you'll be able to put your own logo in this interface here, which is, I think, kind of cool, a nice touch to it. But as you can see, as you're tuning your carbs, if you have a computer, you can even have a laptop next to your motorcycle, you're able to see live voltage readings and live readings for kPa, or voltage as they compare to kPa or kilopascals. Now the next step to do is to figure out our Arduino program. Now this program is already created by me, and ChatGPT of course, but you won't have to do any of this if you simply download this program to your Arduino sketch. Now you do have to go to their website and download the Arduino IDE that they call it. That's the program that reads all of the code, but you'll be able to do that for free on their website. And then all you have to do is upload the program that shows you how you can utilize your map sensor for your advantage with this interface. So very simple, you don't have to do any programming anymore. I've done that for you. And if you're interested in getting that program for yourself, simply email me at the email below and I'll be able to provide you with those files. Now, the only caveat there is that you subscribe to my channel and you hit the like button for this video. So again, we spent about $8 on the map sensor. We spent about $27 on the Arduino, about $12 on the manifold, and another $12 on getting those vacuum ports for our motorcycle. So really, for under close to about $50, you'll be able to have a really cool setup that will allow you to measure the vacuum for your classic Honda or motorcycle, whatever you have out there, to be able to tune your carbs appropriately. So I think all in all, this works great. So now I think it's time to put it on our motorcycle and then see real life readings of how it's working and how you can use it at home for yourself. All right, everyone, so we have our digital carb sync tool here installed on our motorcycle. I just need to connect this last hose here, but I just wanted to show you the bike is not warm yet. It's not hot. You want to do this when it's, warm and you've had it out running for a little while. But as you can see here on the screen, we have the interface here, and I'm going to go ahead and get the bike started. I have my auxiliary fuel tank in place. I'm going to go ahead and turn the ignition on, and I'm gonna hit the starter, and you'll see that the live, I guess you can say live reading will show up here on the screen as the bike is running. So let me go ahead and do that and show you how that reading kind of fluctuates. As we go, we're gonna save the reading, so I'm gonna show you how that looks as well. So here we go. There we go. We have the bike running. Now all we need to do is connect to sensor. We're gonna hit our Arduino. Once it connects, now you don't see a reading right now because I haven't opened my valve. So I'm gonna go ahead and open my valve for the first cylinder, and there we go. So we're getting about 42 kPa. So I'm gonna go ahead and hit save. As you can see, it's gonna save it on the first one, on the first cylinder. So I'm gonna go ahead and close the first cylinder, and I'm gonna open up the second cylinder, and that's gonna give me this reading, which is for the second cylinder. I'm gonna go ahead and hit save. Okay, and I'm gonna go to the third cylinder. I'm gonna close this one, open the third cylinder. That's gonna give me the reading for the third cylinder. I'm gonna save it. I'm gonna close this one. I'm gonna open cylinder number 4, and then I'm going to hit save. Now, as you can see, now we have all the readings for cylinder 1, cylinder 2, cylinder 3, and cylinder 4. And as you can see, cylinder 3 is kind of low, so that's the one that we want to work on. So I'm going to go ahead and open up cylinder number 3, and here I was getting 16 kPa. So I want to go ahead and just come here to my carbs, and I'm going to just do little adjustments to try to get that higher. As you can see, now we're at 25. we go. There we go, we're getting it higher there. So I'm gonna stop there and I'm gonna continue to tune the rest of the carbs. All right, there you go guys, it's that simple. Now this is something that is going to help a lot of you out there. This is a program that you're gonna be able to plug in your tool to your motorcycle, and you're going to be able to tweak back and forth depending on your motorcycle. But the bike is not hot. So once we have it at operating temperature, then at that point, then we can start making our adjustments. But as you can see, the program works awesome. If I were to open this valve, you see how it drops the voltage there. It really works well. This is something that, you know, cost me a few bucks. It was really easy to make, and something that you can make at home as well. So if you want the files for this tool, just send me an email at the email below, and I'll go ahead and send you the files free of charge. Now, all I ask is that you guys sign up or subscribe to my channel, and that you guys click the like button as well. So with that said, thank you all so much for watching, and we'll see you on the next one.